Hello, this video we are going to go over chapter 8, confidence intervals, sections 8.1 to 8.3. Section 8.1, we talk about a single population mean using the normal distribution. Calculate the confidence interval if the population standard deviation sigma is known. We will use G interval. The error found for a population mean, or we call margin of the error, it's the EVM. How we start to estimate the population mean, we need to have a starting point, which is point estimate we call. It is the sample mean, X bar. So we build up a confidence interval estimation, and the margin of the error, EVM, depends on the confidence level, CL. So we need to form an interval. Our estimation will be an interval that's with the confidence level. So should be set up with the X bar minus EVM, comma, X bar plus EVM. The confidence level is the percent of the confidence interval that contain the true population parameter when repeated samples are taken. The probability alpha is related to the confidence level CL, that the interval does not contain the unknown population parameter. Therefore, alpha plus CL equals 1. So confidence level can be expressed as 1 minus alpha as well. And if we use a traditional way by using the algebra formula, we need to find out the G-score for critical value, denoted as G with the subscript of the alpha divided by 2. for the stated confidence level, we can use a TI-83 plus or TI-84 calculator. Here is an example. For the confidence level CL equals 95% or 0.95, the positive critical value is 1.96. How we get it? Press second VARS, select inverse norm, and hit enter. Press the data value starting with the area to the left. And the area to the left should be 1 minus 1.05 divided by 2. That's how we get this 0.975 to obtain the positive critical value as 1.96. The TI calculator can do it by using the inverse norm, okay? And I'm going to draw the chart here, a graph, to show you why it's 0.975. Assume this is a normal distribution here. The CL is the area in the middle here, 0.95. So the tail area, each tail is alpha divided by 2. And the alpha is 1 minus 0.95, which is 0.05. Since we have two tails, each tail's area is 2. It's 2 divided into the alpha, right? So alpha divided by 2, alpha divided by 2, divided by 2. That's how we get this 0.025. And for the positive critical value on the right side here, the G-score, alpha over 2, this point here. The area to the left, you can see it's 0.95 plus 0.025, right? Or we can use 1 minus right-tailed area, 0.025, and get 0.975. That's why when we enter the area to the left, 0.975, comma, 0 is the mean, G-score is 0, comma, standard deviation 1, standardized to get the G-score. That's will give us critical value as 1.96. And the left-hand side will be the negative 1.96, right? We consider the G-score, they are positive, negative G-score, they are symmetric. So next, we are going to look at some example. Let's We are going to look at example 2. Suppose scores on exams in statistics are normally distributed with an unknown population. Pay attention to unknown population mean and a population standard. We do have a population standard deviation of 3 points. Sigma is 3. A random sample of the 36 scores is taken and gives a sample mean of the 68. Find a 90% confidence interval for the true population mean of statistical exam scores. We can use definition algebra formula to get it, or just use a technology such as TI-83 plus or TI-84 calculator. Please state and move to the test, select G interval. And highlight on stats, enter the data values. Sigma 3, X bar 68, sample size N 36, C level 0.9, and hit and come to the calculate, just hit enter. We should obtain the confidence interval instantly as 67.178, comma 68.822. Or we can express it as the population mu, the mean statistical exam score, the true mean population exam score is in between 67.178 and 68.822. If we need to round to the whole number, then the final answer can be 67.2. Oh, this is one decimal, 68.8. If I continue to get the whole number only, since our X bar is a whole number, so we may show the final answer as the population mean in between 67 and 69 as the final answer. Then we need to find out how to calculate the sample size. And if researchers desire a specific margin of the error, then we can use the error bound formula to calculate the required sample size. The error bound formula, EBM, is critical value G alpha over 2 multiply population standard deviation divided by square root of the sample size. And we can reformulate this one to get a better formula for the sample size, which is solve for n. And gets this formula here. Sample size n equal to g go to square, sigma go to square, divided by EVM go to square. Or, personally, I would like to do this way. G square times the sigma divided by margin of error, EVM, whole thing go to square. That way you don't need to hit the square so many times. Use parentheses. So here is an example. The population standard deviation for the age of college student is 15 years. If we want to be 95% confident that the sample mean age is within 3 years of the true population mean age, how many randomly selected cost college student must be surveyed? So sample size equal to G score, the critical value for 95% confident is 1.96. Multiply with sigma 15 divided by margin of error, or we can call EVM. Then whole thing go to square power. We should come out 96.04. Then one thing very, very important. We need to remember to round up to the next whole number. Round up to the next whole number, which is 97. Do not drop off 0.04. Even this decimal digits is very small, but we need to count this one as one sample size and just round up 18 to the 6. That's why we have 96 as the final answer. Next section, 8.2, a single population mean using the student t-distribution. When population standard deviation, sigma is unknown. We need to use the student's t-distribution. Calculate the t-score. The t-score is very similar to the G. There's something different. It's we can use a simple standard deviation, small x, to replace sigma, because sigma is unknown. And in reality, most of the time, actually, we don't know the population standard deviation. So t-distribution becomes particle 1 to be applied. So, but the concept is about the same. We take x bar minus
mean divided by sample standard deviation divided by square root of the sample size. So we can either use a table, t-table, that's the traditional way, or technology such as TI-84 calculator or GeoGebra Classic for the confidence interval estimation. Here is an example with the data. Suppose you do a study of acupuncture to determine how effective it is in relieving the pain. Well, you measure sensory rates for 15 subjects. So that means we have sample size of the 15. With the results given, X bar, the sample mean 8.2, and sample standard deviation with 1.67 to construct a 95% of the confidence interval for the mean sensory rate of the population. We assumed the population mean be normal. So how we do it? We supposed to come out X bar minus X bar plus EBM with the t-score, right? But instead, using the algebra formula of EBM, we can use a TI-84 calculator. Pressing state, move to the test, just select the T interval. For the input, we select stats, enter the data value, X bar equal 8.2, sample standard deviation as 1.67, sample size n equal 15, C level, that means confidence level 0.95, then calculate. We should obtain an interval with a lower limit of 7.2752, comma, the upper limit with a 9.1248. Then we can round off to 1 decimal as our given X bar with 1 decimal. So the true population mean sensory rate is between 7.3 and 9.1. Okay. And we can express as mu in between 7.3 and 9.1. Okay. So when we apply a t-distribution using the critical value in t-score, we can use a table or use technology. Okay. So when sigma is unknown, we use this t-distribution. Remember that. Okay. And technology will make it very easy. Even you use a computer software like GeoGebra, we just need to choose the t-estimate for the mean. Okay. The next section is about a population proportion, 8.3. Some statistical measures, like many survey questions, measure qualitative rather than quantitative data. In this case, the population parameter being estimated is a proportion. We need to count proportion. The confidence interval for a population proportion is given by the following formula here. Let's recognize some notation first. The p-plum represents the sample proportion, which is x divided by n, the success number over the sample size, where x represents the number of the successes and the n represents the sample size. So the q-plum is equal to 1 minus p-plum, because p-plum plus q-plum should be 1. Then the confidence interval for a population proportion is defined as parenthesis, the left-hand side with the lower limit, p-plum minus EBP, arrow bounded to proportion, comma, p-plum plus EBP. Okay. And the part of the EBP here is the same as the G score critical value multiply square root of the p-plum times the q-plum divided by n. Okay. And same thing for the upper limit. P-plum add on the G score, which is critical value, multiply with the square root of the p-plum times the q-plum divided by n. When we work on population proportion estimation, we always use a large sample size. So that's why we work on the normal distribution. We use the G score. Okay. So here is a reminder again. This sample proportion p-plum form a normal distribution with the mean as proportion, population proportion notation is here, right? Comma, we use a small p, comma, square root of the p times the q divided by n, just like a standard deviation here. Then the G-score formula is defined as p-plum minus the p divided by square root of the p times the q divided by n. And remember, p plus q is 1. Here is an example. Suppose 250 randomly selected people are surveyed to determine if they own a tablet. Actually, this number is not 250. I'm going to change it. Suppose 500 randomly selected people are surveyed to determine if they own a tablet. Of the 500 surveyed, 421 reported owning a tablet. So using a 95% confidence level, compute a confidence interval estimation for the true proportion of the people who own tablets. So we can use a TI-84, press state, move to test, select one proportion G interval. One prop G int. Enter data value for the X successor number 421, sample size N 500, and C level as 0.95. Calculate and obtain an interval as 0.81, 0.874. Then we can round off to 3 decimal. We can round off to 2 decimal as desired. So usually we keep a 3 decimal for the proportion estimation. The other approach, you can use the GeoGebra. Go to the google.com and type in GeoGebra Classic probability, then select statistic. And enter confidence level 0.95, success number 421, sample size 500. We should obtain the lower limit 0.81 and the upper limit 0.874. They are same as the way we got from TI-84. Give it a try. It's very easy to get the answer by using technology. If you have any questions, post on the discussion board. We'll go over together again. The last slide is how to calculate the sample size, and when you work on the estimation of the population proportion here. And the sample size formula comes from the arrow bound formula for a population proportion. And we just reformulate. We get this formula for sample size. This is an easier formula to apply other than using that EBP, right? This we also call like the EBP formula earlier. So we can just write down sample size equal the G-score, critical value, go to the square power, multiply P plum, Q plum. P plum is a simple proportion. Q plum is 1 minus P plum. And the EBP that we mentioned before, similar to the EBM, right, is marginal error for proportion. So since both G-score and EBP need to go to square power, you can also rewrite this formula as G-score critical value over the EBP go to the square power together. Then we multiply P plum, Q plum. Okay. So if P plum is unknown, then we need to assume P plum as 0.5, 50% of the chance. Then the Q plum will be the 0.5 as well. Now you can see the example below. Suppose an internet marketing company wants to determine the current percentage of the customers who click on ads on their smartphones. How many customers should a company survey in order to be 90% confident that the estimated proportion is within 3%? Be careful with this. Within 3 percentage points of the true population proportion of the customer who will click on ads on their smartphones. This is the important hint for you here. When P plum is unknown, it's not mentioned on the statement here. We use the P plum as 0.5, 50% of the chance. So the solution for the sample size N equals to the G critical value, 90% will be 1.645. Multiply 0.5 for the small p, P plum for the small p, and another 0.5 for the Q plum, and divided by marginal error, which is the EBP for proportion 0.03, because problem said within 3% points, and we need to convert 3% into the decimal as 0.03. That's why here shows 0.03. Okay. So if you don't like to go to the square power so many times, actually this expression can be written as 1.645 multiplying 0.5 divided by 0.03, whole thing in parentheses go to the square power. That's what bring you same answer, 751.7. Then remember to round up, right, to 752, whole number as the sample size. So practice again, and if you have any questions, please put them on the discussions. We will work out together. See you next time.